guys, how you doing, geometry class? This was my dad. My dad died in 1997. He was helping a friend to paint his house, and he fell off the ladder. The ladder broke or whatever, and he hit his head, and we had to pull the plug on him the next day. And I miss him a lot. One thing about my dad was that he was an extremely honest man. And honesty is really important. So I am hoping that you guys are not sharing any keywords with each other, and you're not letting people copy your notes. Because, you know what? This stuff, this geometry stuff, it doesn't matter in the big picture. What matters is your relationship with God, and what matters is that, you know, you try to always do the right thing. If you're giving answers to other people, then you're just as guilty as they are. And that's something that you need to ask forgiveness from God for. So I'm asking you, please do not do that, because if you get caught, you are just as guilty, like I said, as the other person. So let's all work together. Honesty is always the best policy. If you don't watch the video and I ask you whether or not you watched the video, just tell me you didn't watch it. I would much rather that than you lie to me and then I find out later that you're lying or that you're cheating. Okay? All right, we are doing something really exciting. Page 110. I love this stuff in geometry. It's called Some Ways to Prove Triangles Congruent. The first thing is postulate 12. You guys are going to like these postulates. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. Please put all these notes in your notebook. There's a lot of notes today, and there's also a proof on page 111 that I want in your notebook as well. Okay. This postulate is called the SSS postulate. You're like, what's the SSS postulate? It stands for side, side, side postulate. So if we've got this side and this side congruent, this side and this side congruent, this side and this side congruent, it means the whole triangles are congruent. The angles are going to be congruent as well. So we can say triangle MNO is congruent to PQR by the SSS postulate. Okay? Here's another example. The sides. We've got a side that's 5, we've got a side that's 3, and a side that's 4. These two triangles are congruent. Triangle ABC is congruent to triangle FED by the SSS postulate. There's two other postulates that we're going to learn about today. The SAS postulate, that stands for side, angle, side. You can probably figure out what that means. If two sides in the included angle, and it has to be the one in the middle of the two sides, of one triangle are congruent to two sides in the included angle of another triangle, then the triangles are congruent. So we have side congruent to side, angle congruent to angle, side congruent to side, angle, side. Triangle LRP is congruent to triangle FQC by the SAS postulate. Here's another example. These two angles are 60 degrees, these two sides are 3, these two sides are 9. That means side, angle, side. Triangle MEL is congruent to triangle ODY by the SAS postulate. All right, so that's side, angle, side. That's side, side, side. Now we're going to do the last one, which is angle, side, angle. You can probably figure out what that means. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. So here we go. Triangle. This angle is congruent to this one. We've got a side congruent, and then another angle. Notice that the side isn't this side or this side. It's the included side between the two angles. Okay? Triangle ABC is congruent to FGH by the ASA postulate, angle, side, angle. And then over here we have another example. Two sides of 4, two angles of 90, two angles of 55. Triangle NMO is congruent to XYZ by the ASA postulate. Okay, so that's same side, 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 angle, side, angle, side, angle. Over here, I just want to talk about some terminology that you can use. We have triangle ABC. You can say that the segment AB is opposite angle C. So AC is opposite angle B, and BC is opposite angle A. AB is included between angle A and angle B. So this segment is included between these two angles. Angle A is included between segment AB and segment AC. So this angle is included between these two segments. This angle is included between these two segments. This angle is included between these two segments. So you gotta make sure when you do an ASA and SAS that they're the included angle and the included side. There is a proof on page 111. It gives you the answers right below it. So I want you to look at that proof and see if you can fill in any of the answers before you do it. But the answers are right below it. Please put that proof in your notebooks. You should have a lot of notes come Monday, okay? I hope you have a great weekend. And the key word for today is dad. Have a good one.
Peace.